Hello and welcome to MyScience Tutorials. In today's video, we are going to be talking about Raoult's law and boiling point elevation calculations. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing the notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. Now, in our previous tutorial, we did mention what colligative properties are in the various examples. We also look at the relationship between vapor pressure, depression, and the mole fraction from the law that we call Raoult's law. Now, in this tutorial, we want to look at the relationship between the boiling point elevation and then the lowering of vapor pressure. Now, when a liquid is heated, its vapor pressure rises, and when it is equal to the atmospheric temperature, the liquid boils. Now, the addition of a non-volatile solute to the solution lowers the vapor pressure. Now, once the vapor pressure is lowered, it implies that more heat needs to be applied to the solution for the atmospheric temperature to be reached before the solution begins to boil. So, hence, the boiling point of that particular solution after we add the non-volatile solute increases. Now, if we are using the representation TB as the boiling point of our solvent, let's use black. If we are using TB as the boiling point of the solvent, and we are using T as the boiling point of solution, so boiling point of solution. Okay, we are now saying that our boiling point elevation, which is delta T, should be equal to T minus TB. That means we are subtracting the boiling point of the solvent from the boiling point of the solution, because we know the boiling point of the solution, okay, after we add the solute, will now be higher than the boiling point of the original solvent. So this becomes our boiling point elevation. Now, the elevation of boiling point has been found to be directly proportional to the lowering or the relative lowering of vapor pressure, which means our delta T is proportional to P minus PS over P. Now, in our first tutorial, we made mention of what the relative lowering of vapor pressure is. So where this is the vapor pressure of the solvent, this is the vapor pressure of the solution. Okay. Now, we also look at from the combination of Raoult's law, we also look at the relative vapor pressure being equal to a formula that we said was W, capital M divided by capital W, small m, where we said W is the mass of solute, and then small m is the molar mass of solute. We said capital W was mass of the solvent, and capital M was the molar mass of the solvent. All right, now in this example, from this formula, we know if we are using a solvent, let's say water, we know the solvent will be the same before we add the temperature and before we add the solute. So we are assuming our the molar mass, which is the M over here, the molar mass of the solvent is a constant. So once the molar mass of the solvent is a constant, this formula becomes something that we have like P minus PS on P to be equal to W over capital W multiplied by M. Okay, but we said the relative lowering of vapor pressure over here is proportional to the change in temperature or the boiling point elevation. So we can represent this by delta T being proportional to this. So we have W over capital W multiplied by M. Alright, now if we remove the proportionality sign over here, we introduce a constant that we call KB, then multiply by W over capital W by small m. Alright, so from here, what we need to take note of is the fact that the mass of the solvent, the mass of the solvent is W is in 1 kilogram of the solvent. Okay, so we are dealing with what? 1 kilogram of the solvent. That means the formula here becomes what? Kb multiplied by small w over what? Now the mass is in what? 1 kilogram, which is what? 1000 grams multiplied by what? M. So if we do the substitution very well, we can see that our whole formula over here, everything over here, because this is W divided by 1000 grams, so it becomes Kb multiplied by W multiplied by the 1000 comes to the top, then divided by, let me write it over here. So we have delta T is equal to Kb multiplied by small w multiplied by 1000, all divided by capital W by small n. So this now becomes our what? Formula for boiling point elevation, where we are saying what? Our delta T over here is the boiling point elevation. Our Kb is our what? Molar elevation constant. Molar elevation constant. And W, small w over here, is the mass of solute. Small w is what? Mass of solute. That is in grams. And then small m, small w is the mass. Then small m is the molar mass of solute. That is the molar mass of solute. And capital W is what? The mass of solvent. Mass of solvent. Also in grams. Now, there are some cases where the value of Kb may be given in what? Kb per. So we may have, they say the question will give you Kb per 0.1 kilogram, okay, of the solvent. Now, when this happens, it means instead of dissolving the solute in 1 kilogram of the solvent, which requires us to use this formula to find any other parameter, this time around they are dissolving it in 0.1 kilogram, which is what? 100 grams of the solvent. It means the entire formula over here becomes this: delta T is equal to Kb multiplied by W multiplied by 100 all over capital W multiplied by M. Because the 100 here is because the question is telling us is in what? 0.1 kilogram of the solvent. But when the question does not stipulate whether Kb or the solute has been dissolved in any gram of the solvent at all, we know the standard way to go is what? Is to assume the solute was dissolved in what? 1 kilogram of the solvent, and then we use 1000. But when the question says in 0.1 kilogram, we use 100 to add up to the formula and use. So we need to take note of this. Question 1, that is in 1 kilogram, okay, of solvent. Or this is the standard way. If the question did not say 1 kilogram, you use this formula. If it states this, you also use it. And when the question says 0.1 kilogram, which is what? 100 grams, we use this formula. Alright, so with this brief introduction, let's go ahead and look at some few examples on boiling point elevation. So the first example we want to look at is the boiling point of a solution containing 0.2 gram of a substance S in 20 gram of ether is 0.17 Kelvin, higher than that of pure ether. Calculate the molar mass of X. Boiling point constant of ether per 1 kilogram is 2.16 Kelvin. Alright, so let's write down our solution and look at the parameters that we have. So solution. So the boiling point the boiling point of a solution containing 0.2 gram of substance X. So it means our solute, the mass, which is small w, is what? 0.20 grams of what? Substance S in 20 gram of ether. So it means our capital W is what? 20 grams of ether is. So the boiling point elevation, so the change in boiling point, okay, as a result of this is what? Delta T is what? 0.17 Kelvin, okay, higher than that of pure ether. Alright, so calculate the molar mass. So we have to find M. small m, okay, of x. Boiling point elevation constant is given to us as what? So our Kb is what? 2.16 Kelvin. Alright, so with this parameter, let's go ahead and calculate our molar mass of the substance X. Alright, so we know that the formula delta T is equal to what? Kb multiplied by small w multiplied by 1000, and the question also said per 1 kilogram, so we are using 1000, divided by capital W by what? Small m. Now if we make m the subject over here, we cross multiply, we get delta T by capital W by small m is equal to Kb by W by 1000. So if we divide all by what? Delta T by W, capital W, we get our molar mass to be what? Kb multiplied by W by 1000 all over what? Delta T multiplied by capital W. So it means our molar mass is equal to Kb, which is what? 2.16 multiplied by the W, which is 0.20, multiplied by 1000, all on what? The change in temperature over here is 0.17, then multiplied by the capital W is 20. So if we put everything here into the calculator, we are going to get 127.05 as our molar mass. So it means the molar mass or the molecular mass of what? Of substance X is what? 127 gram per mole. Alright, so let's have a look at another example. Example number 2. Acetone boils at 56.38 degrees Celsius and a solution of 1.41 gram of organic solid in 20 gram of acetone boils at what? 56.88 degrees Celsius. If K of acetone per 100 gram is what? 16.7, we have to calculate the mass of 1 mole of the organic solid. So let's go ahead and look at our solution. So we have acetone boils at this temperature. So the temperature for the pure solvent is which is our T, is 56.38. All right, no, this is TB. All right. So and a solution of 1.41 gram of organic solid. So it means our small w is what? 1.41 gram. Okay. So we have 20 gram of acetone. So it means capital W is what? 20 grams, and it boils at this temperature. So it means our T is what? 56.88 degrees Celsius. Now if K of acetone per 100 gram is what? 16.7, so it means our Kb is what? 16.7. We have to calculate the mass of 1 mole of the organic solid. Alright, so let's go ahead and look at that. So we have from here we know our delta T is equal to the formula Kb multiplied by small w multiplied by, because they are saying what? If K of acetone per 100 grams, so we are using 100, all divided by what? Capital W multiplied by small m. Now we know our delta T over here, okay? Our delta T over here will be T minus TB, so it becomes what? 56.88 minus what? 56.38 to be equal to our Kb is what? 16.7 multiplied by our small w is what? 1.41 grams, then multiplied by 100, all on our capital W is 20 grams. So our small m is what? We don't know, so we are going to make that the subject. Alright, so if we make m the subject over here, we get what? Our 16.7 multiplied by 1.41 multiplied by 100 divided by 20 multiplied by 0.50. That is, if we subtract this from this, we get what? 0.50. So our molar mass, okay, is equal to 235.47 gram per mole. And now the question is telling us to calculate the mass of 1 mole of the organic solid. So we now have the molar mass of the solid, and we know that the mole is what? 1 mole. And we have the molar mass to be equal to what? 235.47 gram per mole. So we can easily calculate the mass of the organic solid. Okay, so the mass over here, the mass of the organic solid, we know mole is what? Mass over what? Molar mass. So if we make mass the subject, which is W, we get mole multiplied by what? The molar mass. So our mass in this example will be our mole, which is 1 multiplied by what? 235.47. Okay, so our mass of the organic solid is what? 235.47 grams. Okay, so this is the mass of our organic solid. All right, let's have a look at one final example. Now, in a cultural determination, 22 grams of benzene was used as a solvent. All right, so let's write down our solution. So we have here 22 grams of benzene was used as a solvent. So we know our capital W is what? 22 grams. Now the reading on the differential thermometer before and after adding 0.5, so it means our mass of the solute is 0.586 of naphthalene. So the reading on the differential thermometer after adding before and after adding 0.586 gram of naphthalene were this and this. Okay, so it means our change in temperature from here straight away we know is 1.799 minus 1.262, all right, respectively. Now, in a separate experiment using the same amount of benzene, but this time adding 0.627 gram of an organic compound X, the thermometer readings were this and this. So we have to calculate the molar mass of X. So it means the first values that were given in the first experiment, we had to use it to find Kb, and after we find Kb, we had to use that value of the Kb in the second experiment to find the value of what? X, since we are using the same organic solvent. All right, so we've been given the molar mass of naphthalene, which is what? Small m, to be what? 128. All right, so from here we move straight away and we look for the value of our Kb. So we know delta T is what? Kb multiplied by W multiplied by 1000, all on what? Small m by capital W. Okay, now in this case we have to find what? Kb. So we make Kb the subject. So if we make Kb the subject, we have our formula to be what? Delta T multiplied by m multiplied by capital W divided by small w by what? 1000. Now we know Kb is equal to the change in temperature as what we have over here will give us a value of what? 0.537 multiplied by m. The m is what? 128, so we have 128 here. The capital W, okay, is 22, so we have 22 here. On the small w is 0.586 multiplied by what? By 1000. All right, so our Kb from here is equal to what? 2.58. So this is the value of our Kb. Okay, now that we have the value of Kb, we have to use it to find what? Use it to find the molar mass, okay, of the organic compound X from the second experiment. So let's list down the parameters in the second experiment. So in a separate experiment using the same amount of benzene, so it means the same amount of benzene means our capital W is what? Still 22 grams. Okay, same amount of benzene, but this time adding. So our mass, small m, is what? 0.627 grams of organic compound X, and we know the mass of the molar mass is still 128. So the thermometer readings were this. So we have our delta T will be what? The bigger one, which is 1.963 minus what? 1.269. All right, so if we do that subtraction, we are going to get from here, if we do that subtraction, we are going to get 0.694. so all we have to do is to write down the formula, this formula, and make what? The molar mass over here the subject. So if we make molar mass the subject, we have the formula to be what? Kb multiplied by small w multiplied by 1000, all divided by what? Delta T multiplied by capital W. Now this is for the separate experiment. So all we have to do is to substitute these values into this formula and find the molar mass of the compound X. So let's go ahead and do that. So our M is equal to, let me rewrite the formula. We have Kb multiplied by W multiplied by 1000 on what? Delta T multiplied by capital W. So our M is equal to what? Our Kb that we found was 2.58 multiplied by our small w was what? 0.627 multiplied by 1000. Now the values on the temperature, the difference was what? 0.694 multiplied by the same mass of the organic solvent, which is what? 22. So if we input everything here into the calculator, we are going to get 105.95 as our molar mass. So it means the molar mass of the compound X is what? 105.95 grams per mole. Okay, so this is the value, or this is the molar mass of our compound X. So thank you so much for watching. I hope this tutorial was useful, and I will see you in the next video. Bye bye.